What
Gosh,
would you say?
I can't even look past 2 months from now without
Really?
I'm not really sure how it's gonna play out. But
Yeah.
I mean, I think that there's going to be like a lot of solutions, and I think like when the U.S. looks at it critically, we have to like take a look at things like the existing grid is 70% of that grid is 25 years old or older. I mean,
Yep.
it's starting to meet end of life.
Yep.
You're looking at an increase in consumption in the U.S. of 10%, probably by 2028. And that doesn't
Hmm.
necessarily mean you have power at the right places.
Right.
That's just the overall consumption. And then a tripling of power in the next couple of decades. The
Yeah.
government wants to throw like a billion here, 3 billion here at a problem that's going to cost $2 trillion.
Right.
And I mean, for any politician to say, hey,
Right.
we need $2 trillion is kind of political suicide.
Yeah, and especially when panels and batteries are so cheap. I mean, this is what drives me nuts. You know, I mean, and the residential solar market is so inefficient, and mainly because of consumers' ignorance, if you really ask me.
Mm-hmm.
Because we can really build assets, solar panels. Uh, I mean, I'll leave the batteries out, but you can build solar systems for really $1.50 to $2. But most of California is still paying 3 to 4, maybe even sometimes over $4 a watt, when Florida is paying 2.25. And the only reason that's happening is because everybody's pricing solar's value just a tad bit under the utility pricing, which varies, is double in California, and all the value in the middle is being lost between all the middlemen. And I mean, they're making fat margins, but consumer is not benefiting from it. And in the meantime, we're giving them a really bad product, which is
Oh yeah, I mean, I
and
agree.
we're
I agree
complaining
with you.
about that it's going to cost $1 trillion to upgrade this 100-year-old system. I think the solution will have to be consumers empowering themselves with solar plus batteries and DC power in their
Mhm.
own properties, and it's they're going to get 3-year payback on these investments if they do it right, and if we design the solutions right, or maybe 5-year payback. But it's definitely be much better deal than they're getting now. Um,
Oh yeah,
and
no,
I don't
I
think the grid
completely agree. Like
needs to
people,
die. I think the grid can live in this equation as an exchange medium, but they're going
mhm.
to have to innovate themselves as well. I mean, we're
Yeah,
talking.
and that's why and that's why we work so much on the microgrid side of things is being able to because these major corporations, data centers, EV charging stations, they are not waiting for an upgrade.
No, no,
they're
they're
not
doing their
banking
off-grid
on the
solutions.
government coming in. Yeah,
Yeah.
yeah, they take a look at it and it's like, whoa, this is how many
Oh, we got
years
to
now?
wait 2 years for a transformer to be shipped and an
Oh
interconnection
yeah.
permit. No, we're like they're just gonna put the batteries and the panels in their backyard and power their
Oh
data
yeah,
centers
yeah,
that way.
exactly. Put the panels and the batteries in the backyard in a residential sense, and some of the larger commercial industrial facilities,
Yeah.
just larger systems, but really for self-consumption at those locations. It's kind of like it would be like I live in Nevada, and if you're out in the middle of the
Hmm.
desert, it's phenomenal. You could probably buy acres for pennies on the dollar. But if you build that plant, where are you going to push the power to? I mean, the transmission lines are
Yeah.
forever away; they're completely loaded.
Yeah.
So, really having a more distributed architecture is more efficient, and it's also safer in terms of like redundancy, reliance issues, really ensuring the power is where the power needs to be and that people are
Yeah.
protected in terms of if there is a grid outage or disturbance.
Yeah. Yeah. I mean, we talk about 10% increase in consumption, but there's a possibility we might have 30% or even 2x by the end of this decade or in the next 10 years, let's say.
Yeah.
And that can't all come from the traditional, you know, central power, centrally, uh, what's the right word? Central power stations. It has to be built behind the transformer, behind the meter at the point of consumption if we're going to have that much additional capacity.
I completely agree, and the permitting for it is so much easier. The speed to market is so much faster,
Yeah,
and after like quantifying like what your capex and opex are, you're safe. You know what you're paying for power.
yeah,
It's not like this huge variable in the future where like you're subject to wild fluctuations, potential cost increases. You can
yeah.
see the effects of it, and you can get the power that you need today instead of waiting for power that might not even eventually come. I've worked in with some utilities and some clients wanting to put in EV charging infrastructure in certain states, and when they go to the utility, the answer is we just can't do it. It's not even a question of like when. It's almost like it just gets shut down.
Because they don't have the know-how? Is that why? It's just too new. It's different than what they've done for the last 50 years,
They're,
and they
they're
just
not willing to commit to a time frame. Like they just can't say when they would be able to get the power there.
so then, I mean, those must be the times when you guys get a call. Like, is that when you
We
guys?
get all sorts of phone calls. Yeah, I mean, I get a lot of interesting phone calls. So I mean, we work with like charging depots and developers and people who aren't going to wait, people who
Yeah.
are going to make sure that they can generate on site the power that they need for these like charging depots. And if you take a look at like some of these charging depots with like 100 stalls of high power charging,
Hmm.
you don't even necessarily own the adjacent 200 acres, so you're not going to power it with that. So you're going to use linear generators. You might use fuel cells. You might use solar. You might use a limited grid connection. But you'll use a combination of things to be able to achieve what it is that you need to effectively have the power at that point where
Hmm.
it might not be readily available.
Yeah, and I guess that is one of the secret sauces of Dynapower is to know, like, you guys deal with all sorts of different complicated problems, and then
Mhm.
you kind of create that solution that kind of glues it all together. Would that be a fair way to
Yeah,
describe that?
yeah, yeah.
Or
So much of the secret sauce is in the power electronics. How do you take these diverse assets that operate and output on different voltages, and then how do you bring it all together in one cohesive system that allows it to work? But
yeah,
really, like helping and kind of going back to some of the previous conversation on some of these standards is arriving at something that's scalable, something that's a little bit more standardized, cookie cutter
yeah.
that really can scale faster. But that's going to really depend on like industry alignment.
And I guess, I mean, even in those cases, I don't know, like maybe a big data center that's deciding not to wait for the utilities to connect them to power. Like they design their own behind the meter, behind the transformer solution. Don't you still need some approval from the utility or some sort of permitting jurisdiction entity on the maybe on the construction side?
There is
Or
permitting, but it isn't waiting for an interconnection. So the interconnection is the thing that really
yeah,
takes
so you get the construction permitting or the real
time.
estate related permitting done, but you don't need to. But ultimately, that device that you're powering is still technically connected to the grid. Like you're not completely disconnecting it from the grid, right?
Correct. Yeah. And it's
But you
been
can,
overlooked in some instances, and other utilities are starting to want to know what you're doing on the DC side.
right?
So some
Because
utilities
you're
do want
still
to have the
connecting to some electrical appliance or component
information.
which is also connected to the grid, technically speaking. So they do want to know, rightfully so, because it might affect
Yeah.
the grid, right? It could
Oh
be.
yeah, and you need to be able to provide assurances that you are not going to push back like a bunch of like power, like
But
you are on the
right,
hook for those considerations.
yeah. So now let me ask you this though. Can you standardize that type of solution? Okay, maybe it's a great thing to do it for big data centers or other types of industrial applications, and you sell 100 of them or a couple thousand of them. Great. But can you do that type of design and roll it out across 100,000 homes to start
I
with? And
know, and that's like
like
one of the big
like
questions. That's why we're
because
kind of
that's
like,
that's what the
yeah,
world needs, right?
yeah,
I
yeah.
feel like.
And I mean, that's almost like these days, like sampling the AHJs to see like who's going to push back on like on what things and how like standards are interpreted. I mean, if it's a standard, it's a standard, so it would probably be okay once
Right.
it's like into the NEC. But in some of these instances, yeah, I mean, it's variable. Some of these utilities don't have experience, as you probably have seen, with these types of like products and solutions, so they're
Yeah.
kind of at a loss. And yeah, and I mean, there's how many thousands of utilities in
Yeah.
the
Two, three
U.S. And
thousand. Yeah.
yeah, you want to get all like everyone to get on the same page with all of this. Like that's an interesting ask. That's a big problem with the transmission and distribution upgrades. I don't
Yeah.
know how you're going to like get everyone like on the same page when I think there was a like a transmission line that went through like Louisiana, and I think Louisiana like was partially on the hook for some of the costs involved, but there was no distribution or anything that came off of it, so they reaped absolutely zero benefit for something that they had to pay for.
Wow. Wow. Yeah. I mean, the utilities have it tough too. Like we gotta make sure everybody wins in this solution. So I don't know what. Well, it sounds like you guys are working on a whole wide-ranging solution um, series of solutions, and it'll be interesting what comes out as the winning, I guess, DC architecture out of this. And
Yeah, and I mean, like we're with Dynapower and our like just historic experience and kind of working with some of these like emerging and nascent projects, it's I think it's important to like be able to take our experience and be able to help others understand that as well in helping to define some of those standards and considerations, and not just like following what somebody else might want to put in place, but really taking some of that experience and knowledge and like helping the industry out to kind of help lead some of that conversation and help really like define what some of that should potentially look like and get everyone in the same room. I mean, we can be competitors but still like work together and coming up with what's best for the environment, what's best for the consumers, what's best for industry, like just what's in everyone's best interest. And there is that area that is what is in everybody's best interest.
yeah, yeah, great. Well, as we're nearing the end of our conversation, any I guess any wishes from the universe? Like if the universe could bring some things your way, what would that
I'm
be?
going to sound like a madman, but this is my I want micro reactors. I am so sold on the need
For micro
for
reactors, like nuclear modular reactors?
yeah,
Yeah, yeah,
containerized nuclear. I honestly
yeah.
think that is one of the big missing
Computerized.
components.
Yeah, obviously. Yeah, digital, all kind of. Yeah, I get that.
Yeah, I mean, it's providing the base load. It runs
Yeah.
24/7. It can really work on some of those grid inertia problems, which are a little
Hmm.
difficult to solve in some of these like solar and battery projects.
Yeah.
And it provides like a really compact solution. I mean, again, if we go back to the like example of EV
Hmm.
charging and not having the 200 acres next door to you, yeah, it would be nice to have a few 20-foot shipping containers that kick out
Yeah.
the same power for the next 15 years.
Yeah. And are you seeing applications of that like close to real like happening? And what would be the cost if
What's interesting, the cost one is always throwing me off. I've tried to calculate the cost, and
yeah.
it is a wild, unattainable number. Like it sounds too insane. So I need to work on the cost. I can't go into
You
too
mean
much
like it's too
detail.
expensive? Too expensive?
Yeah, the estimated cost of the reactors is extremely high.
Yeah.
But again, I don't have the hard data to be able to pull from to be able to
Mhm.
like to fact check whether or not that's like a real number or not. I'm sure at some point it probably scales and makes sense, but there are solutions that are out there that are
Yeah.
mobile containerized micro reactors. It does exist.
It does, huh? So and they're being used. well, obviously they're being used in submarines and stuff
And
right
some,
now.
yeah,
Yeah, I
exactly.
mean,
And
right?
maybe the people that did the submarine stuff, maybe they're working on some other stuff too. So
No doubt. I guess I mean, I like that idea. I think we need base load, and and that's a very nice, clean way of powering that base load. And it's my only concerns with it is that it might be tough. Like you might bump into the NIMBY problem, like not in my backyard. Okay, I like the idea, but I don't want that thing
yeah,
next to
that's
my
the problem.
building.
It's gonna
Yeah.
be, it's gonna be,
Yeah.
yeah, like, yeah,
And
exactly.
then
That,
and then the cost is unknown. Whereas the cost for solar and batteries,
oh
uh,
yeah, I mean,
I mean,
pencils.
it's solar is 10 times cheaper than it was 15 years ago, and I've seen it with my own eyes go down 10, 20, 30% every year. And battery seems to be on a similar trend. Um, and yeah, are we going to be able to have enough batteries, lithium reserves, and all that? That's a big concern, and maybe there'll emerge some new technologies. But yeah, no doubt, it's the early days of this standardized DC architecture future that might be, I guess, the new paradigm that we all walk into soon.
Yeah, very true. It's I don't wake up and hate my job. Like it's is very
Yeah,
interesting on a day-to-day basis. It's great
yeah,
to be able to speak with people like you, other industry leaders, labs, academia, about all of these emerging technologies. It's a very exciting time to like live through this like next industrial revolution.
yeah, yeah. Well, great having this conversation with you, John. Thank you for your insights and your know-how that you shared, and we will probably continue doing more of these in the near future. So,
Look forward to it. Yeah, thanks again for the invite.
pleasure to have you. Thank you.